Today's notes are on rational exponents. Just as a review, remember that all numbers can be classified as complex numbers, and those are numbers of the form a plus bi. So they have a real part a and an imaginary part bi. Now, under complex numbers, they can be split into two categories, imaginary and real. So imaginary numbers are the ones that have an imaginary part. So for example, 2 plus 3i, they have a real part and an imaginary part. If it just has an imaginary part, it's called pure imaginary. So for example, 2i, or square root of negative 1, which is I, or square root of negative 6. Real numbers, on the other side, are not square roots of negatives, and those can be classified in two ways, rational and irrational. So remember that rational numbers are ones that can be made into fractions, and irrational numbers are not fractions. For example, 0.23 repeated forever, 23, 23, 23, 23. That could be made into a fraction because it has a repeating pattern. Or 0.5, which terminates. Okay, that's the same thing as 1/2. So if a decimal repeats or it terminates, then you know that it can be made into a fraction and it's a rational number. Obviously, like 2/3 is a fraction, so that's a rational number. Some examples of not fractions, the most famous, pi, square root 5, square root 7. These numbers go on forever, and they never repeat, so they don't have a repeating pattern. Now, today's exponents that we're going to be discussing are all rational exponents. So they're all fractions. Okay, so I first want to start talking about nth root of a. So for example, if I say what is the nth root of a, and n is 4, and a is 256, so in other words, the fourth root of 256, what I'm talking about is finding a number that you multiply by itself 4 times to get 256. And so the answer is 4, because 4 times 4 times 4 times 4 is 256. So how about example 2, the nth root of a, if n is 3 and a is negative 125. In other words, I'm saying what is the cube root of negative 125, and that's negative 5. Negative 5 times negative 5 times negative 5 is negative 125. Okay, the fifth root of 32 is 2. And then the second root of negative 9, or the square root of negative 9. Well, square root of negative you can't do in the real number system. So we would say that there's no real solution. If you're talking about imaginary numbers, then the answer is 3i. So it just depends on if you're allowed to write your answer as an imaginary number or if they're only talking about real solutions. Now notice also that when you do a square root, you don't write the 2. It's just assumed. So the next concept that we're going to be looking at is going from a rational exponent, so like a fraction, to a radical form, so an expression with a radical in it. So you're going back and forth from radical form to exponential form. Now, for example, if I say x to the 4/5, that 5, that number underneath the fraction, is the root, and the 4 is the power. So I can write it as the fifth root of x to the 4th, or the fifth root of x all to the power of 4. So notice that the number in the top is the power when you rewrite it, and the number in the bottom, that's the root when you rewrite it. So one way that I kind of remember this is I think about that division sign in the fraction as like the ground, and that the number underneath the ground is the root. So the number on the bottom is the root. So power 4 root 5. Okay, you can like match up the colors there. All right, so let's look at some examples down here. 12 to the power of 3 over 2. So I want to rewrite that using radical notation. And all I'm doing is just rewriting. So notice the power is 3 and the root is 2. When you have a root of 2, you don't have to write it. It's assumed, square root. Okay, next one. Root is 5, power is 4. And this last one here, you first need to rewrite it with a positive exponent, so 1 over 8 to the power of 2/3. And now 8 is the power and 3 is the root. Okay, so 1 over cube root of 8 squared. All right, next we're going to go the opposite way. So I give it to you in radical form, and you have to write it in exponential form. So on this first example, square root of x. So you have to think, what is the power and what is the root? Well, when you have a square root, you don't write the squared. So when there's nothing there, you have to assume that it's a 2. And when there's no power, it's assumed that it's 1. So a square root is the power of 1/2. On example 2, the power is 5 and the root is 3. So y to the power of 5/3. And on example 3, power is 2, root is 4. And that can be simplified to 5 to the power of 1/2. Okay, so here you're evaluating. In other words, you're finding the actual answer, like what is 16 to the power of 3 over 2. And you need to be able to do this without a calculator. So remember, power is on the top of the fraction and the root is on the bottom. And it's always easier to do the root first. So here we're going to do square root 16 to the power of 3. Square root of 16 is 4. So you have 4 to the power of 3, and then 4 to the power of 3 is 64. Okay, number 2, 1 to the power of 5 halves. So 5 is the power, 2 is the root. So that means the square root of 1, all to the power of 5. Now square root of 1 is 1. The power of 5, well, that's still 1. Number 3, make sure when you have a negative exponent, you rewrite it first. So 1 over 8 to the power of positive 4/3. And now 4 is the power and 3 is the root when you rewrite it. So cube root of 8 all to the power of 4. Now cube root of 8 is 2. So you have 2 to the power of 4. And 2 to the power of 4 is, not 8. It is 16. So you get 1 over 16. Okay, next one, 27 to the power of 4/3. So here 4 is the power, 3 is the root, so cube root of 27 all to the power of 4. Cube root of 27 is 3, and 3 to the power of 4 is 81. Number 5, all right, another negative exponent. So first we have to rewrite it, 1 over 49 to the power of 1/2. So that becomes square root of 49, and that's 1 over 7. Okay, next one, notice the negatives outside here, so that's negatives not being put to the power of 3/2. So you have negative on the outside, and then square root of 9 all to the power of 3. Square root of 9 is 3, and notice I'm keeping my negative outside. 3 cubed is 27, and then you put the negative on, so it's negative 27. Now number 7 is very similar, except there's parentheses, so this time the negative comes inside the square root. Now if you're operating in the real number system, you cannot take the square root of -9, so there's no real solution. And that's it.